So what I prepared is or what I try to do within the next couple of minutes is try to zoom a little bit out of the topic and give you some ideas about what are the challenges at the science policy interface, and a lot of things I mention or will not mention you heard already. So I basically start with a short introduction how science is, or doing coastal science is actually done at the moment. Then talk about some of the barriers in knowledge production, touching also this issue, of course, and propose a way of overcoming these barriers. Now, what are we usually doing? Not only in coastal science, but also in other disciplines, is our approach to understanding coastal systems is to cut the big picture into smaller pieces. I mean, pieces of meteorology, of geomorphology, within our disciplines, and even within the disciplines, they're cut into smaller pieces, and at the end you're becoming an expert in your field. Now the problem is somebody has to put this puzzle together in order to get the full picture, and this is what you mentioned, and also you mentioned the interconnections to other not only scientific issues but also policy dimensions and laws and so forth. Doing this, it doesn't happen automatically, and we as scientists, and there I agree, is first of all, we are experts in our own domain, and by creating knowledge, we are also creating non-knowledge, So what is actually needed to address these kind of problems we heard yesterday and today is systemic or integrative approaches to adequately understand physical and social or societal processes and their interdependencies, of course, and an action-oriented or applied approaches to develop and implement. And here I talk about context-sensitive or context-appropriate and socially robust strategies. And I briefly explain what I mean by that. With context-sensitive, I mean proposed solutions who fit into this local context, not a concept which was basically taken from another country or another context and then be implemented, and later on you find out it doesn't work. And with socially robust, I mean that that it is an agreed solution among different societal sectors. It is not a pure scientific strategy proposed. This I thought is maybe I should mention some of the challenges. ICSU had a visioning. ICSU is the International Council for Science. So this is. I'm too close, or okay, okay. It sounds like you don't hear me anymore, but this is probably my own. Yeah, okay, better. Thank you. ICSU is the International Council for Science, so this is the biggest scientific organization, and they had a visioning process where they invited all scientists around the globe working on global environmental change to a visioning process, which are the challenges of the future, and some smart people, you can't read it, but I can provide it. This article published in Science, these are basically all Nobel Prize winners, Paul Crutzen and so on. They came up basically and formulated 5 so-called grand challenges. And I don't want to go into detail, but there are 5 challenges of forecasting, of up to innovating. So basically the entire process chain of scientific work plus the implementation part. They are also freely available as a report on the website, and I would like go and have a look. I think it's really important. because out of this process now came a 10-year program called Future Earth. And this is set up by ICSU, but basically the ICFA, the biggest funder of global environmental change research, so the NSA, the German Research Foundation, all the national funding agencies are basically putting money into that. And this framework called Future Earth is basically the scientific framework for the next 10 years when we talk about global environmental change. And I mean, the topic here is very, very much related to global environmental change. And therefore, I thought this is really important to mention. Now, going back to my partly to my own research, and to be a bit more specific, what are critical challenges? I'm not an artist as the person yesterday. I could not draw it much better, but it looks complicated, but it is not. What I try to graph here is basically, on the one hand side, the environment, on the other side, society. Then you see static and dynamic, and you see specific stressors or multiple stressors. So if you do science, coastal science, or if you try as a policymaker to address a certain issue, you will find yourself somewhere in there. Well, if it can be a pure environmental issue, like, I don't know, hydrological runoff, or a pure societal factor. It could be a static parameter or a dynamic, or it could be a single stressor or multiple stressor. Now, if you would look at the science, what is done globally, you would get this picture. Meaning most of the science is actually done on the environment, increasingly with regard to society as well. And I'm talking about global environmental change with regard to coastal systems here. There is much more work done on there are much more static assessments than dynamic assessments, and of course there is more work done on specific stresses than on multiple stresses. So basically, what we actually lack here is assessments which can integrate both societal and environmental factors in a dynamic way with regard to multiple stresses. And this is, truly spoken, not easy. It's not an easy task. And I tell you a little bit why. And I call this a challenge of understanding because it's at the process level. We are far away from understanding all processes. And this is basically due to the process characteristics, because they're multidimensional. And we heard that in various forms. They have economic, they have physical, they have cultural aspects. They are dynamic. That means driving forces change over time. They're not the same in 5 years or what you measured 5 years ago. They interact. That means the driving forces influence each other. They are socially divergent. That means they vary individually and among and within societal groups. Not everybody is affected the same way. And they are scale dependent. That means they vary temporally, spatially, and with the unit of analysis. So these are process characteristics, and every scientist knows the challenges these characteristics pose. One example here at the process level I put here is this so-called teleconnections. You know, this kind of butterfly effect that you deforest parts in southern Brazil, and suddenly somewhere else on the globe the temperature increases. And honestly, we discover more and more of these teleconnections. Now, on the system level, there are further challenges waiting, the challenges of integration. And also these we heard during these 2 days in various forms. There is this language conceptual dissonance among scientists. If you just talk terms like sustainability, risk, although everybody understands, if you go into detail, they mean completely different things to different scientists. And of course, decision makers in policy and practice have a different concept of these. The availability, quality, and transferability of data and models is another barrier. And the processing and dissemination of knowledge, and this is basically should be illustrated with this pyramid, this so-called knowledge pyramid, is another barrier, because pure data is not knowledge. Information is not knowledge. And wisdom is basically having the capability, to have decisions. Unfortunately, you can't read that, I guess. One example is, or a good example here is climate change or disaster risk reduction. If you just look at the history of climate change, and here are some of the core data. Fourier identified the greenhouse effect in 1822. A lot of people are really surprised, because they thought the IPCC did all the work, related to climate change. But if you look at the history, it's much older. That's one thing. The other thing is, it was not like a science-driven thing. I mean, all the discoveries were made in very different fields of science, and they were not interrelated. I mean, not necessarily other people did know that he discovered this and this was done there. So it was not like a strategic endeavor, scientific endeavor, as a lot of people perceive climate change today. And Paul Crutzen received the Nobel Prize in 1995, and this is, from the Sun British newspaper, you may know. It is to illustrate, and this was published in '86. To illustrate that there were very different concepts still. Basically, if you look at the climate change science and what was known there and what was known outside of this scientific domain, it was quite different. And the other thing it illustrates, even within the scientific system, it takes time, As we said, there are other scientists, they have different opinion, they have to argue. So first of all, and that takes time. If you think about the first discoveries until basically the Nobel Prize, which is here, this is the ultimate, you are right, or basically you have been right because what you did was 25 years ago, So it takes time, And of course it takes time to implement as well. And this is my last challenge here, is the application, applying knowledge. And there are, as we also heard in various forms, also a lot of barriers and obstacles waiting. Institutions and authorities, they have divergent foci, time frames, budgets. They have overlapping, often unclear responsibilities. The funding mechanism, to give you an example from the scientific system, they are often incompatible with the regard to scope and duration. So they give you a one year project to study global environmental or adaptation to global environmental change, which takes place within one generation. How do you want to do that in a 1 year project? You would need long-term funding. On the other hand, they ask for designed for short-term results. If you can't deliver scientific results within a short period, you're in a worse position. Whereas a lot of the processes we have to study operate on different scales. Now, the mode of knowledge production, and this is basically what I studied, is also a barrier. Streamlining knowledge into one index, high geographical differentiation, cultural heterogeneity, social plurality, and so on. Disaster risk index, we all know it, or climate index, so and so. Cities have it, nations have it, people like it because you can compare it, but they hide a lot of other aspects. Now, this pipeline mode is not very efficient and has severe pitfalls, and I try to give you an example on that. This is a State of the Union address of U.S. President. Please read it. Important are the green parts here. It is about renewable energy. So basically, the president is asking in his state of address to move quickly on the energy issues. And this nation, and this is the US, has the resources and the capability to achieve our energy goals if its government has the will to proceed, and I think we do. And this is the political will we were discussing yesterday. Now the question is, who said that? Little game. Obama? Huh? Gerald Ford in 75. Depressing, huh? So much about political will. You need the context, you know, to move on. This is what should illustrate this example. Now, the pipeline knowledge production, this is called pipeline knowledge production mode. And this basically says there is a problem, which of course is identified by scientists. They decide what is a problem. We heard that as well. Then research is undertaken, of course, by scientists. Knowledge is produced, which is then published. And then this knowledge is basically transferred to the outside academia world, where it will trickle down, adopt, and diffuse. Now, unfortunately, I have to tell you that this still very common mode of production is very, very ineffective. And maybe we can discuss this in more details later on. But here I just put some of the pitfalls, you know, and why this production mode is basically inefficient. If you look at the types of barriers which occur between these blue boxes, you could group them into three big groups. Functional barriers, that means different objective needs, scopes, priorities. You could a second group would be structural factors, different standards, time frames. The reward system, the scientific reward system, is also a huge barrier, because we are rewarded by writing scientific papers and give a talk at the scientific conferences and not talking to a local decision maker in coastal management, you know. That doesn't reward. So this is our own system. And the third group are social factors. I mean, different cultural values, understanding, trust and mistrust, you know, the language, the scientific language, and so on. Also here I can go, I can tell many stories about this, but I just want to illustrate that there are different factors. And of course there are ways to overcome these barriers. Unfortunately, it's a bit too small. I didn't expect this would be such a big room. Actually, we have the meeting, but I don't have to go into detail, but basically what I think, and this I will conclude with, in order to efficiently implement coastal science, but also other type of science, I would recommend, based on both the research I did, but also the experience I gained with this coordination position I had, you should include multiple types of expertise, because you increase credibility. Meaning practitioners as well, meaning local knowledge, you know, not only scientific knowledge. I would engage you to collaborate, to engage in a collaborative knowledge production to increase legitimacy, because people will not argue against you if they have been involved in this process. Usually they don't, you know. Usually they do if they have been excluded from certain processes. And I would propose context-sensitive solutions, which I explained what I mean by that. I mean, because they you increase relevance, meaning this is really these solutions which we will collaboratively do together will fit this problem, and it's not imported from somewhere else. So my pledge would be to jointly co-design and co-produce knowledge together with coastal researchers, policymakers, and practitioners. And as I can see, you are much, much more ahead of many others which haven't realized that, because there are people sitting here in this room together, and I think that's a good start. And a lot of problems can be solved by communication, as we heard already today and yesterday. And I'm happy to continue this communication now in the discussion table. Thank you for your attention.
Any sort of questions?
I have a remark. What he made is that although scientists can give certain views and directions based on only on science, ultimately in policies, societal issues override scientific basis. I think policies are determined by politicians, not by scientists. And invariably, only in IPCC to some extent, it's kind of balanced, I would say. Because, as you rightly said, a summary for policymakers, every word is discussed in the plenary. And you can't write a word which is not acceptable to everybody, and one person can change that word. Whereas in most of the policies in India or in many countries, I have not seen policies are written by scientists or jointly. It's usually written, and ultimately it is left to the final version is left to the politicians who make policy decisions. So what happens is, the science gets nudged over, and societal issues override the policies. And then surprising, CRZ is supposed to be siding with this society, but even they are not happy. I don't understand this. Western Ghat proposal, it was the same. They were diluted, and they went into more into societal issues. Now Kerala is totally rejecting the Western Ghat report. So I don't understand where we are heading.
If I can just add to that.
Oh, give me the chance to reply.
Just one sec. I think he wants to add, so you can sort of respond.
You can answer later. I'll just add. So what I wanted to say was that, in a sense, I think scientists do write the policy. It is at the implementation level, and that's where every policy, in fact, needs to come with a manual, or actually realize how it will be implemented. Sometimes the policy, like in this case CRZ, and we can discuss at length, but I still feel, CRZ is completely dictated by or written by scientists. The line or MS Swaminathan committee also again has been formed, but it's the implementation where politicians take a hold, I feel.
Yeah.
Yeah, I think that's true. That's very true.
Yeah, but I think it's as I put on my last slide. There are other advantages. There are certain advantages. One is this credibility, certainly, and the relevance, and coming up with really socially robust. And this is very often when policy fails to be implemented because it's not accepted by the people, So that's one thing. The other thing with regard to IPCC, there is another big advantage or step forward, which is if you do not agree with certain statements on climate change, as we discussed before, you can only do this in a scientific way. You cannot, these times are over now that you can say it doesn't take place, it doesn't happen, which a long time ago this was possible. You just said, I don't believe it, and that's it. So you did your part. This is not possible anymore. So if you don't believe, you have to prove it scientifically, and this is actually what happens. And I think this is where maybe I disagree a little bit and go towards this direction. I think that's a normal business in science. I think this yes. Well, if you then prove it scientifically, and then other people, and scientifically means transparent. That means I can reproduce your results, so. I wouldn't say that this is nothing. It's there is a lot of things gained through these processes. In fact, that IPCC is so successful, and with successful I mean if you look at the history and what is to the product. I'm not saying the quality and what is, if everything is correct in there. But there is no other product which is reached with such a process to a relevant aspect of global importance in any other domain. Not in the disaster risk reduction. There is the Yogo framework for action. It's a framework. It's not binding. I mean, forget it. I mean, if we would have something there like the IPCC, like a really disaster report, it would be a major step forward. I just want to mention or highlight that this is really you should not underestimate that.
Everybody is looking at some regulations or ideas which will apply to the whole country or whole state at least. Now when you go to the local level, you find that this is not applicable, that is not applicable. So you have a lot of such things. So is it what would be a good idea to start from bottom up, or have an overarching guideline kind of thing, not regulation, and then you have local standards which you set it up?
Yeah, why don't you start? I mean, I heard it yesterday or today. I mean, and people obviously know very well in this state the administration is very effective or efficient. You said, yesterday we heard that works very well in that state, or this state is the only state. So people know it anyway, what works and what doesn't work and so on. So why don't you start with a state or a case, where you think, well, that's for this and these reasons are appropriate because they're most advanced or pretty much doing that what we aim to reach, and then try to really follow some of the recommendations I give, and I can give you more if you want. But basically try to integrate different expertise, try to overcome these barriers in a collaborative way, and you will see the outcome is much better than compared what is done in any individual case alone, And then maybe if you showcase this, that will give you some more power, and good examples you cannot hide. You can hide for a certain time maybe, but that's maybe a way forward. I don't know.
The sense that there are good practices and bad practices is very much there with the policymakers, the scientists, as well as the project proponents. So yesterday, I think there was this discussion about the need for cumulative assessments, cumulative environmental assessments. Now, to follow the rule saying that I'm only going to look at EIA of my project, when you know that there are other industries operating or other factors operating, is fundamentally abdicating the responsibility that you have as an enlightened scientist, the ability to go beyond your TOR, looking at the broader policy framework. Why do we say, that's not my business, I will only look at my TOR? And I think we then create disasters like the Uttarakhand ones, where when you say 64 hydel power projects, I mean, surely, and I don't know who are the ones who did the EIAs there, but what I'm told is that it was Roorkee that has done a large number of EIAs. Now, surely they knew, surely we know where to build our roads and where not to build our roads. When you build roads cutting through the way we did. So I think I don't agree at all that the scientists involved in those processes didn't know. I mean, they knew the hazards, but there is a certain policy imperative or a political imperative to say, yaar, ye project ko pass karana hai somehow. And when you operate with that, and that's what I mean, that this whole business of trying, I mean, you look at CRZ or any of our regulation as something to be overcome or something to be somehow managed, then we run into trouble. So my basic argument is this, that the need for interface, when you talk of, look at local knowledge systems, look at policy elements, look at the larger development paradigm, look at best practices elsewhere, because that's the real mandate which we need to be able to respond to. So,
May I add, I think, something which might be of interest? If you look at the industry, which was criticized several times and so on, they are much better actually than the science system because they are co-producing their products. When I was young, when I was a kid in Germany, car industry, very important, they said it takes 10 years from the idea of the designer having a new car, a new model, until it's actually driving around, it takes 10 years. And it was true, it was like that, but it's not like that anymore. There is no chief designer designing a car and then they produce it and then let's see if it's successful or not and people buying it. I mean, if you look at today, Apple or, I mean, you name it, all the products are co-produced with the potential consumers. They ask them in advance what color is your preference, how big the screen and the buttons should be and so on. They don't produce something and then let's see if the people like it, if it sells or not. They are not stupid. A long time ago, they found out it's better to involve the potential users of our product. Now, scientists still believe we produce, I mean, it's not only we produce the knowledge, we identify the problems, you know, we identify the problems, what is relevant now. And if you identify the problem which is not relevant, you don't get any funding. Let's face it, it's like that, you know. And we are so ignorant, I mean, not everybody in science, I mean. But I think I can say that if you look at the industry, I mean, we could learn a lot. And as I said, they did it a long time ago, you know, and much more successful than scientists in many ways, you know.